Assalamu alaikum viewers. Today our topic of chemistry is Sp3 hybridization of carbon atom. Okay, how carbon atom undergoes Sp3 hybridization. To understand this, we have to understand first that what is S, what is P, and what is 3, and what is hybridization. Actually, carbon atom contain different shells. So this S and this P are the subshells of its shell. Okay, like S is a circular in shape and P have dumbbell shape. Okay, carbon P3. 3 means 3P. P means this one P, the other, and the third one. It's PX, PY, and PZ. Okay, hybridization means mixing of the orbitals. These three and this one, total 4 orbitals undergoes mixing. Okay, you can add a plus sign in between them. When they undergo mix, they form, because they're total 4 orbitals, they form 4 different orbitals having this shape. What about their other sides? Actually, when this S enter in these shapes, they get fat and these sides become smaller. So we cannot make this in the picture because it is difficult to understand the picture then. So it is a simplified form. What happened? When this 1S and 3P, PX, PY, and PZ mix together, they form 4 new orbitals, 1, 2, 3, 4. These 4s are degenerate. Degenerate orbitals. What do you mean by degenerate orbital? Degenerate means they have same energy. When they are in this shape as P, X, P, Y, P, Z, they have different energies. This has low energy, these have higher energies, and so on. But when they undergo mixing, they undergo hybridized, they become degenerate. Mean all of these, since they mix, they become equal in energy. So all these have same amount of energy, same shape, but in different direction. So these are degenerate orbitals. They have the same name. Like these have different names as PX, but these 4 should have same name. That is Sp3. This orbital is Sp3. This orbital is Sp3. This orbital is Sp3. Okay. So these 4 new orbitals are formed that are equal in energy, so they are known as degenerate orbitals. Okay, so let's go toward carbon's electronic configuration. What about electronic configuration? 1s, 2, 2s, 2, 2px, 2, 2, 4, 5, 6, 7, 8, 4, 2px, no, 2. Okay, so what happened? This 1s2 is first shell which is complete, so this does not involve in bonding. This shell which have less number of electrons is involved in bonding, so we will write 2 as 2. We can write like this, and no, this is not x. So 2px1, 2py1, and 2pz0. There is no electron here, but according to some principle, when equal energy orbital is available which does not have any electron, this electron will move toward here to get its separate position and move with same spin as compared to it means. So it moves with the same spin, so we can write 2s1, 2px1, 2py1, 2pz1. Okay, so you can see all these have 1 electrons in it. So when we make this system, we can add one electron here, one here, and one here, okay? All these have 4 electrons, so when this orbit form, all the sp3 orbits contain one electron in them, okay? So what happened? This sp3 will form 4 bonds because it have single electron. It needs 1 electron to complete. It needs 1 electron. It also needs 1 electron to complete. So what happened when this carbon atom form bond with hydrogen? Hydrogen means 1s, or 1 means like this. It has 1 electron. When this s, actually 4 hydrogen atoms will connect with this. So you can make this like this. It's called overlapping. When this orbital and this orbital form a bond, they become overlap, okay? So you have to understand the difference between hybridization, degeneration, overlapping, okay? These terms you should know the meaning of these terms before performing any hybridization exam. So what happened here? This bond overlapping is known as sp3s overlapping, okay? S means this s electron of hydrogen and this sp3 is of carbon hydrogen bond, okay? So this what we make here, we make CH4, okay? 1 carbon, 4 hydrogen makes carbon hydrogen 4 bonds. Methane, how can we write it in a simplified form? We can write it like this, okay? They have an angle of 109.5 degrees, okay? And the shape is what? Tetrahedral. You can add like this, okay? So this is our sp3 hybridization. If you want to understand sp2 and sp hybridization, you can look at our other videos. You can watch it and understand about other hybridizations. Thank you so much. Please subscribe our channel for more videos.